All right, welcome back. So now we're going to actually apply some of those limit properties and fundamentals to do some typical problems. So here we go. Reading the directions here, it says using limit properties and fundamentals, answer the following questions. Show the application. This is huge for me. Show the application of the property or fundamental before substituting values. So I don't just want to see like numbers chucked in, right? A page full of numbers and arithmetic. I actually want to see you rewrite expressions, equivalent expressions using these limit properties. So let's take a look. This says if the limit of f of x goes to 5 is 3, so that's just a given, then the limit of x squared times f of x goes to 5 equals. So now you need to look at this and say, okay, here's a product of two functions, right? Both of these are functions. So you just learned in the prior video that the limit of a product is the product of the limits. So I can rewrite this as I like to work down here, right? I can rewrite this as the limit of x squared as x goes to 5 times the limit of f of x as x goes to 5. And then you should be saying, all right, well, you just finished up before this limit property, the power one, right? Limit of the power of the limit. So I could do the limit of just the function, in which in this case is just x, the limit of x as x goes to 5, and then raise that answer to this, in this case, this power. That's the limit of the power is the power of the limit. And then here I'm just going to rewrite limit of f of x as x goes to 5. I want to see this at the very least. In fact, really, this is the line I want to see. This line here. This is demonstrating that you understand the properties, and like a Band-Aid, you did it all in one shot. You ripped it off, right? I like that. This step you don't need to have, but for note flow, I like to include it. Okay? The last step now is that arithmetic step, right? That's when you're chucking the numbers in. So you're like, all right, what's the limit of x as x goes to 5? Well, that was the second limit fundamental. The limit of x as x goes to 5, that's just 5. So then you have 5 squared. And then the limit of f of x goes to 5 here, that was given to you in the problem. That's just 3. And so your answer is 75. So if I just saw what I see in red here on a test or any sort of assessment, no chance I'm giving you full credit, right? I want to see you apply and demonstrate the properties, okay? All right, let's move on. Let's take a look at this guy. So you got two givens now. In this case, you have the limit of f as x goes to c. I'm going to say that's a. The limit of some other function, g, as x goes to c, that's b. And then I want the limit of this mess right here, this linear combination. So how do I view that? Well, I first have to view this as a sum, obviously, or hopefully it's obvious because there's a plus sign there. So what do I know about the limit of a sum? It's the, you guessed it, sum of the limits. So I can write this as the limit of 5f of x, that's the first part of the sum, as x goes to c, plus the limit of 7g of x as x goes to c, right? That's the limit of the sum is the sum of the limits. Now, you might be saying, wait a minute, you got some more stuff you can do there. Because in the first part of this sum, you have a constant times a function. And in the second part of the sum, you have a constant times a function. And you learned that constants can be moved through functions. So that's what I'm going to go ahead and do here. So I'm going to rewrite this as 5 times the limit of f of x as x goes to c, plus 7 times the limit of g of x as x goes to c, right? Again, what do I want to see? I think you should be able to go straight to here. You don't need to show me this step. In other words, you can do two properties in one. Do limit of sum of the limit, and at the same time, pull out the respective constants. There's no reason why you can't do that. All right, and now you just kind of substitute in some stuff. So it was given that this limit here was a, and it was given that this limit here was b. So that's basically your answer, right? Just 5a plus 7b, all right, using your limit properties. Moving on, let's take a look at this guy. Got a weird little radical there. Ignore that. All right, I'm going to give you that the limit of h of x as x goes to 3 is 18. And then I want you to do the limit of this radical. So this was very similar to that example I gave you in 6, right? You have the limit of a radical. Well, guess what? That's the radical of the limit. So I can rewrite this as the radical of the limit. So limit as x goes to 3 of h of x over x, right? But then you're like, well, wait a minute. That's a quotient inside. And the limit of a quotient is the quotient of the limit. So I can rewrite that as the limit of h of x as x goes to c divided by the limit of x as x goes to c, right? And this whole thing is radical here, okay? So again, this is like the note flavor step where I kind of take my time doing it. And this is the, all right, I get the properties step. I'm going to apply all the properties one and rewrite it. This is the one I want to see. Okay, you can show me both, but I think you can be efficient and get right to here. So now it's time to chuck in some answers, chuck in some values. So the limit of h of x goes to c, they told you that was 18, right? And the limit of x as x goes to c, I don't know why I'm writing c. I'm on another planet. It's not c, it's 3. The limit of h of x goes to 3 is 18. And the limit of x as x goes to 3, that's a fundamental, that's just going to be 3. So 18 divided by 3, last time I checked, square root of 6. And that's my final answer, okay? So not too bad on that one. All right, let's take a look at this guy. Limit of q of x as x goes to 6. I'm going to tell you that that is 3. And then I want you to do the limit as x goes to 6 from the left, which that seems a little weird. We'll get to that in a second, of 8 times q of x. All right, so what do I do here? Do I view this as a product? I could, but if you listened to my video before this, you'd probably say, no, you don't want me to though, because when one of the factors in that product is just a constant, we want to really think of that as let's pull the constant out. So I can rewrite this as 8 times the limit as x goes to 6 from the left of q of x. Now, you might be thinking, well, you didn't give me that. You gave me this limit, right? You gave me the limit as x goes to 6. And so you're like, well, wait, think about that, right? What does that really mean? We say as x goes to 6, but what's implied there? It really means the limit of q of x as x goes to 6 from both sides. So not only from the right, but also from the left. So this was actually given to you, right? So you can go from a two-sided to a one. You couldn't do the opposite. If I gave you the limit as x went to 6 from the left, you couldn't assume that the limit as x went to 6 from both sides was the same. But the way we did it here, you're good to go. So now that's the step I want to see, right? And now it's just 8 times the given value, which in this case is 3. So you get 24, all right? Easy breezy, lemon squeezy. All right, so let's take a look. We got 2 more problems and we are done. So here we go. Limit of fx as x goes to 0 from both sides. That's -3. And now I want you to do the limit of this guy. Oh, this is nothing new. You should be able to do this. Honestly, if I'm you, I'm pausing this video right now, and I'm going to try and do this one by myself. Okay? Now that you're back, let's do it. Limit of a difference, difference of the limit. So you can rewrite this as the limit of 11 as x goes to 0 minus the limit of f of x as x goes to 0. This first guy is a constant. Limit of a constant, constant itself. That's just 11. This next guy was given. So that's going to be -3. So you get minus 3, right? We learned in middle school that means add. So you're going to get 11 plus 3. So your answer is 14. Again, don't care too much about this step. Don't care too much about that step. Really, really, really want to see that step. Okay? An application of the properties. All right, let's do this final question here. It's a good one. It says use the graph below. So this time I didn't just give you the limit. I'm going to have to, make you earn your keep. You're going to have to use the graph. So you got the limit of this mess here. So how do I view that? I'm actually curious, can you apply all of the limit properties in one shot, all right, and rewrite this thing, okay? See if you can do it. Pause the video and do it. All right, I'm going to do it with you. So if I'm applying all the properties, first thing I do is I view the product. I have this product, this function, this factor, times this. So there's my product. Limit of a product, product of the limit. So I'd have the limit of this times the limit of that. Now, in the first part of that product, I have a sum, limit of sum of the limits. So I would have the limit of x as x goes to 2 from the left, plus the limit of 1 as x goes to 2 from the left, but that would be wrapped up times the limit of g of x as x goes to 2 from the left. And that would be me applying all the properties in one shot. Limit of x as x goes to 2 from the left, that's that identity function where the input and the output are the same, right? So I know what I'm going to be tracking to. So that's going to be 2, right? Doesn't matter if I'm going from the left or the right or both sides. The answer would be 2 there, whatever I'm approaching. This is the limit of a constant. That's the constant itself, right? And then this here, I have to go to the graph. So here's a graph of g of x, find 2. I didn't put a scale on here, so shame on me. I should have. I'm just going to tell you that each one's worth 1. That's not always the case, but it is here. So now if I'm approaching 2 from the left, as x goes to 2 from the left, what is my corresponding functional buggy tracking to? Looks like he's tracking to that value there, 1, 2, 3, 4, 5, right? And if I wrote that, my order of operations is all screwed up, right? I can't forget these parentheses. 2 plus 1 is 3, times 5 is 15. That's my final answer. All right, so that's just messing around and doing some limit, property, and fundamental questions. All right, see you soon.